Good afternoon, and welcome to the session where we're going to focus on cross-sector applications. We're going to kick off with a set of 4 videos, which show some of the work that's been funded through the ISCF Robots for a Safer World Challenge. All of the videos and all of this areas you're going to see now, they will concentrate on inspection and maintenance tasks, and they highlight that type of task in a number of different areas, different sectors. But the key thing here is that they're demonstrating the potential for cross-sector application. In every case, you could see, okay, it applies in that particular sector, but I can see that that's a generic piece of facility, a generic function that could also be applied elsewhere. So we're going to focus on that aspect of this section. So while the technology is pretty impressive, the real message here is that robots can make a step change difference, often to operational performance levels or to the level of knowledge we have about a particular asset. And it's those generic things that we're really interested in. And it's that's going to generate the significant interest in and investment in deploying robotics in the future. So first up, we have Headlight AI, and they're going to introduce us to the Prometheus Project, which has got the potential to allow inspection of the previously completely uninspectable.
Prometheus is a reconfigurable drone designed and developed to explore underground voids, mines, and extreme environments. It is expected to do that safely and autonomously. The drone is also expected to be deployed and retrieved through a 150mm borehole. Now, in comparison to traditional surveying approaches, the Prometheus drone offers huge cost savings and reduces risk to human life significantly.
The University of Bristol is working closely with other partners in the project to integrate planning, sensing and flight control software. Alongside this, we're also working on part of the deployment and retrieval mechanism to allow us to operate in boreholes. As part of this work, we've put together this prototype vehicle. This vehicle has the same electronics, powertrain and the same layout as the final vehicle. Using this vehicle, along with the flying arena here at the Bristol Robotics Lab, we're able to test the software in a controlled environment before we then take it out into the field. As part of our first field trials, this vehicle carried a prototype of the Dragonfly sensor. This allowed us to capture our first in-situ, in-flight data. Alongside that test, we were also carrying out some more basic flight tests to help us understand the effects of the complex flows that occur in confined spaces and their effect on multi-rotor performance. Alongside that, we're also looking at how our radios degrade as we start to go around corners and lose line of sight.
As part of Prometheus, we're developing a lightweight 3D sensing solution which generates a 360-degree 3D point cloud. This point cloud will be used for SLAM and navigation when in the confined spaces.
We are working on the exploration tasks in confined spaces. These tasks become highly challenging due to constraints imposed by the nature of the environment. For example, there are dead-end branches and bifurcations. So to deal with these challenges, we develop advanced exploration and navigation planning at RAI Holloway. Also, recently, we tested our planner with the Snake Beach mine data. As you can see in this problem, the task is the robot needs to explore the environment and get back home within 20 minutes. As we can see here, the robot is able to navigate autonomously to unknown regions and map the areas.
So I hope you've enjoyed and are excited by what you've seen so far. 2021 is equally an exciting year for us. We've lined up Integration Test 3 and Integration Test 4. We're going to further demonstrate the drone capabilities in a real mine-like environment. So please stay tuned for more videos. And for further information, please do visit our website.
Great. Well, thanks very much for that. I think the confidence needed to fly an autonomous drone inside a cave where you can't retrieve it is pretty amazing. So that's really special if you can make that work. So really well done. Okay, next up is a project from Rolls-Royce called Cobra. And as you'll see, that's a really, really appropriate name. Okay, thank you. That's a futuristic view, but it does neatly set out how this type of inspection robot can be used so that you don't have to disassemble a massively complex structure, which obviously would take that asset uptime would disappear. And obviously, if you can make that work, that's got a real bottom line impact in terms of the way you would operate complex bits of electromechanics like that. So next up, we have Process Vision and their industrial process inspection robot that's taken on a really good challenge of operating in live high pressure systems in petrochemical and chemical processing industries.
Introducing Process Vision, a leading company developing the latest game-changing robotics technology. The use of robotics to improve efficiency in the oil and gas industry is becoming a hot topic. Discussions with engineers made it clear that a robotic solution for internal inspection and maintenance was much needed. The research and development team at Process Vision have responded to this need by developing Insight, a robot snake. It comprises a maneuverable optical system which can monitor the internal operation of processing systems while the plant is operating. The small diameter snake provides a live video feed to give real-time operations the ability to troubleshoot, inspect equipment, and remove fouling. Clean heat exchangers without shutdown. Clean unpickable sections of pipeline while at pressure. Inspect and clean gas separators and treatment systems without interrupting production. Designed for high-pressure combustible gas systems, Insight will safely access systems via existing tapping points and become a versatile tool to perform a number of tasks that currently require a plant shutdown. Insight has the ability to investigate the internal condition of piping and pressure vessels. Additional tools will enable operators to troubleshoot problems and give process engineers the clarity to make clear, evidence-based decisions. Let us help you optimize your operations and reduce your risks. Speak to us today to discuss how Insight can benefit your business. Visit processvision.com for more information.
Okay, that was really great. I think we can all see that the potential of being able to really operate in a live system at high pressure has really got a potential to have a big impact on processes, maybe process efficiency, and obviously accelerating that type of excellent technology within the UK really potentially gives us some really good global impact. So last of all, we come to the final video. This is the Nautilus Project, and it's a collaboration between quite a wide range of stakeholders, looking at the real challenge of inspecting inside petrochemical storage tanks, where the robots that do this need to work in a potentially explosive environment, as well as fit through some fairly small access ports. Okay, well, thank you very much, everybody, for the videos. Obviously, in a moment, we'll move over to the panel where the people who've been at the core of those pieces of work will give us their insights into this. What I want to do, though, is in this session is not so much to focus on the technology that's just been demonstrated, although that is obviously in all of those cases very, very impressive. It's actually the way that this technology can change and improve both operational models, business models, how it can impact, and in particular, how it can impact across different sectors, how we can get that cross-sector impact. And very much that cross-sector impact is about addressing what I describe as the deployment challenge. That's the ability to identify the return on investment that end users like Network Rail or even potentially the airlines that maintain those fleets of aircraft need to see that return on investment so that they invest to accelerate the development, because we're not there in terms of market deployment yet in any of these cases, but further investment and further acceleration of that technology is really where we have to go. And it's about pivoting from what is a technology push into a market pull. And if that's going to happen at scale, and it's going to happen at speed, then it's going to have to be cross-sector in order to be able to get the scale of costs and scale of infrastructure that you need to deliver those types of systems. So we need to understand partly about the lessons learned and transfer best practice, but it's also about building scale across sector, because that helps build skills, and it helps build confidence that the technology actually really does what it says it does. So I'd like, first of all, to turn towards the panel as a whole and address my first question to Paul Stockwell from Process Vision, with that impressive snake robot going inside that real piece of chemical production equipment. So you talked about the ability of that equipment to really affect the process efficiency of some of those processes. Could you give us a bit more of an insight into what sort of impact that has and how you go about communicating that impact to the end users, who really probably don't understand very much about robots and probably see them as a bit of a threat in some respects?
Yes, certainly. Well, you're quite right, actually. Some sectors, certainly the maintenance sectors within the oil and gas industry, might see robotics as a threat. But what we're trying to do is integrate what we're doing with robotics into existing infrastructure and existing practices. So on a shutdown, so refineries, gas processing plants usually go through a 3-year or 4-year cycle where they maintain everything as best they can, but they shut down every 3 years so that they can replace parts and do stuff that they can't do whilst online. And what we're trying to do initially is say, well, if we do a pre-shutdown inspection at high pressure whilst the process is running, then we can build up, if you like, a shopping list of everything that needs replacing and the corrosion that's taken place and stuff. Build up work packages of things that need to be done prior to the shutdown, rather than wait until the shutdown and then find out what needs to be done. So we can increase the efficiency, if you like, of that shutdown. And then applying this technology to something like tube and shell heat exchangers, it's phenomenal, the decrease of efficiency that happens with fouling in a tube and shell heat exchangers. And they're used, across the board in food and beverages, pharmaceutical manufacturing, as well as oil and gas. So yeah, it's an interesting project really for us.
So, I mean, the impact really is on the bottom line of those industries. It's the value of the robot is probably relatively insignificant in comparison to the long-term benefit people would get by using them.
Yeah, and that's very much the message that we're trying to get across, is that robotics actually have that rare ability to improve safety as well as improve the bottom line. So certainly in the oil and gas industry, if you want to improve safety, normally there's a cost involved in doing that. Things take longer or whatever, but actually using robotics, you can dramatically improve the bottom line by not having to shut down, or not having to shut down quite as long. And the other thing, of course, if we take the efficiency of tube and shell heat exchangers, there's that progressive drop of efficiency. Whereas if we can get in more often, we can keep that efficiency up to its maximum more often. And that, I think, is where the biggest saving is going to be.
Okay, thanks, Paul. I'd like to turn to James now from Rolls-Royce. We saw there a view of how you might integrate, in effect, inspection into the insides of an engine using that type of small snake robot. Does that mean that when I know you don't sell engines, you rent them, but if you have an engine, would it have the robot already in it, or is this something that would be distributed around your sort of maintenance centers? And how does that, again, would that change your business model again, or is that something that you would then have to sell on to people who do the maintenance? How would that work?
Yeah, so that's it's an interesting question, lots to unpack. But I suppose the quickest, easiest way to think about it is we're not looking at making robots here that are going to be built into the engine. So there'd be when a scheduled maintenance requirement kind of pops up, then that's when this type of thing might be deployed. So in that case, we'd be looking to probably deploy a range of these devices in strategic locations around the world, probably at our main service bases. But you could imagine quite easily that it could be scaled up to be including all of the airlines that are interested in pursuing such a thing. And because we're looking also at remote operation, it's possible that another airline could perhaps purchase a device and we could control it from our central location just to kind of improve or inspection or actually kind of deploy another service perhaps. So yeah, there's a range of different ways to look at it. It's quite early days from a kind of snake robotic perspective for maintenance within the aerospace world. So we wouldn't want to rule out any kind of market disruption, but that's not something we're looking at just now, because what it really does for us is provide us with a tool to perform different tasks that we can't do today. So if we have that kind of capability, we want to be able to ensure the engine runs for its scheduled time, and that this type of thing allows us to do that.
And I'm assuming also this is going to have an impact on engine design, which is obviously going to have, there's a long cycle to that. And so it would take a long time before we'd even see these types of things in engines. You give us some insight into how you then design for a robot that doesn't quite exist yet?
Yeah, so in a way, we've got two different ways of looking at that again. So one of the best things about working in aerospace maintenance is that everything we do now is ideally kind of backwards compatible. So that's exactly what we've been doing, looking at the current fleet of flying aircraft engines and seeing what type of sizes and kind of forms would be allowable to provide us with access. And that's the root of our specification for the Cobra robot that we showed you the video of. Clearly, there's an impact later on when we're looking at design of new engines. So we are quite invested in design for service. So it's not just design for repair, but maintenance and inspectability as well. We're also kind of bleeding in other things such as embedded cameras, for example, so that we could perform an inspection on the engine on its own. So that's another project that was funded by this ISCF round called Inspect.
Okay, great. Thanks, James. I'm going to turn to Headlight AI. So Puneet, you've got a lot of information coming back off your sensors. You can't actually get into some of the places that you want to inspect to even see whether or not what you're seeing with the robot is actually really what's there or whatever. How do you go about interpreting that data, and how do you make that sort of, how do you certify that? How do you make sure the data you're getting out is valid and interpreted in the right way?
I think on the certification and in terms of the actual checks on the autonomy software, there is a lot of work being done in terms of how do you validate and certify AI. Prometheus as such is not truly focusing on how do we certify the AI behind it. The idea was, can you actually demonstrate beyond visual line of sight flight with a drone where it has to make decisions where the pilot has absolutely no view of the drone. So from that is a hurdle that we need to sort of overcome. And again, there has been demonstrations through other drones that have in much larger voids have demonstrated that they can follow a set of waypoints which have been set by the human
in terms of the set of waypoints it has to follow. Prometheus is unique in some ways that it has to be deployed through a very small hole, and it could be that we have an initial map of the void that it is going to go in the first place, because what most of the companies do at the moment is drill a hole, deploy a sensor down, get an initial scan, and that is what they have. But it is about interconnected voids that is the most interesting. So it was about how the drone collects the data and processes the data on the fly to make a decision. It's on what is the next safest waypoint that it needs to go. And that we have looked at very, very carefully, and we haven't overloaded the drone with very, very heavy, power-hungry, large-range sensors. But we've gone with strict requirements that have been set by the end user, but also the environment, because we know that these are confined spaces and these are tight spaces. So it is a combination of optimizing the sensors, but also the AI behind it, based on and demonstrate levels of autonomy. So yeah, that's the.
I mean, what I could see, although you haven't got line of sight, you've got at least line of radio sight. So you've got. Do you see a point where you might even be able to do things without even line of radio sight?
It also depends. So, for example, this is about cross sector. I mean, we also do a lot of work with water and wastewater utilities in particular. Again, those are deep assets, really, really large confined spaces. The issue there is whether the asset owner would let you do such a thing or not, and it comes down to ATEX certification. Some of them are relaxed, some of them are not really. Here with Prometheus, I think we need to have some form of a link. So when we deploy it through a borehole, we always have a base station, and it's always a constant comms as long as we have a line of sight with the drone. But at the moment, the current version of the drone does not have any kind of radio contact. But that is certainly has been explored in the past, where images have been sent back over ground, just purely using sort of radio. But again, then you have limitations in terms of the amount of time it takes to get that data back. And here we also are limited with the weight and the payload the drone can carry. So we have very limited time to be down there. So the goal is to be absolutely safe, not to crash into the mine, and to collect as much data as possible, because that can be post-processed, and we build a new map, and next time the human can actually look at that map and then give it some set of waypoints which are much safer to sort of follow.
So again, you highlight the point that obviously between different sectors there may be very different criteria that have to be applied to the design of the system and even the certification processes. Okay, so I'm going to move on now to Mike. Mike, really interesting to see RS components getting involved in this type of area. I wonder whether you could just give us a bit of a background on what that is, how that works, how did that come about, and give us some insight there.
Yeah, it's a little interesting. The project initially was started off by a company called Munition Limited, who were in NDT testing, condition monitoring, reliability, etc. And in 2019, RS purchased that company as part of an ongoing development within RS. So that's that was the, if you like, a catalyst for how RS got involved.
And what's the engagement going forwards?
With the project, we're project lead within the project and responsible for all the commercialization, exploitation, and as part of RS's global reach, it's made it quite interesting as to what else it brings to the party. I think everybody looks at RS as being, as I did when I was an engineer, everyone had an RS catalog on the bench, and you might have said, get it next day type thing. And what we're trying to do, or what we are doing, is moving away from, if you want, a commodity supplier to a solution provider. And part of these innovations, which is the robotics side, is only part of what is happening within RS. It allows us to get more, if you like, more skin in the game and more at the front end of understanding the challenges and the requirements of what customers need, which also allow us to position a lot more goods and services. If you like, the basket of goods that we now can position, and we understand where it fits, we start to be proactive sellers rather than reactive. You know, we're reliant on a customer asking for a new board or a transistor or something. Now we're actually beginning to understand a lot more of the requirements and the problems that they are in being offering solutions. So it has broadened that. You know, we have actually managed to get an extension on the project for validation, and as we speak, the robots being deployed in the UAE doing trials on 10 water tanks that we've got in comparison to what you would call the state-of-the-art robots, just to make sure, you know, we've got things in line. And as you know, one of the other panelists has said, you know, when you look at certification, that's one of the major problems that we serve, is that, you know, when you try to deploy it within a fuel tank, yeah, it's experimental. It's not being done before. So who's going to be the first? And the potential, if it doesn't work, is disastrous. So, but you can build your test tanks, which we did, and we tried it in oil, and but nothing sort of like, you know, replicates the real thing. So part of what we're doing is trying to, if you like, more establish its use within a safer environment to give people that little bit more confidence. And like I say, it's not that it's not been done before. Lots of robots now are not ATEX certified, etc. And again, that's another aspect of what we've been able to glean from the project. Is obviously we've got a number of other partners within it who are building the robots and design them, and they've then come to us and said, right, here's the parts we use. Can you then go out and locate where all the ATEX parts are to replicate these? So it has got a lot more mutual benefits than first it would seem.
Okay. I wonder, Paul, could just to come back to you on this business of you know, cross-sector certification, because I could see that your robot obviously, you know, would work across a whole range of different sectors and a whole range of different things. Do you see that certification issue, that sort of multiplicity of certification and sort of also, you know, our ROI calculations as well, going to be very different in each place? How do you approach that?
Yeah, well, I've been working in the oil and gas industry for most of my career, really. So we're quite familiar with ATEX, Class 1, Div 1, and those kind of hazardous area certifications that are required. And it does require thought from day one of the design about how we're going to tackle the issues. So, so what we're doing at the moment is putting hydraulic links actually for the articulation and traversing in, which means that we can move the vast majority of the heavy lifting work, if you like, to put it that way, outside of the hazardous area. So generally around a gas pipeline, for instance, within a meter of it, that's classed as zone 1. So the presence of combustible material is going to be there more than not. And then outside of that, there's class 2, which means there's 40,000 hours a year that will have combustible gases present, and then outside of that, it's a safe area. Different places move around a little bit, but in order to be able to put something into a hazardous area, you do need it certified by a notified body. That means even under a fault condition, sometimes under 2 fault conditions, it will not create a spark.
Yeah. Sure.
So yeah, you need to be able to demonstrate that and test that independently.
So there's an interesting question that somebody's raised in the chat. It says, how do you recommend we develop awareness of our solutions to in the robotics sector and demonstrate that cross-sector capability? So Puneet, I wonder, you know, you've got a really unique solution there, and I can see that it would apply in a lot of different areas. What sort of things are Headlight AI doing to try and look at other sectors that are out there that might be able to take on this technology?
I think for us, it was kind of the other way around. I mean, we started in late 2017, and we got our first sort of funding through kind of, you know, venture capitalists in 2018, and that was the focus by then. Was we wanted to provide improved sensing and sort of capabilities that could help drones and other robots to go into confined spaces. That was an area which we felt was something kind of the whole subterranean world was kind of sort of not looked on. Suddenly, we felt that the water and the wastewater and the utilities had this massive amounts of assets all over the country, and majority of them, they don't even know where these assets are. And believe it or not, every minute there is somewhere a construction company drilling into an asset which they shouldn't be. So we just felt that something had to be done about it. So that's where we sort of started focusing. And then the questions were like, okay, what the robots are, how are the robots going to be down there? What is the current state of the art, and what are the operators used to? Because we never wanted to do anything without not sort of consulting these guys, because they have been using robots for the last 10, 20 years. So we wanted to bring in step changes and want to make their lives easy. So we started with wastewater. At the Innovation Lab, we sort of looked at network rails problem, and it was kind of the vision that they put forward about just drilling a hole and putting a robot down, which then felt like, okay, that is an area clearly has got applications. We definitely knew that there are applications in the oil and gas and probably other sectors, but ATEX always came around, and wastewater was a bit of flexible, as Paul just mentioned. Like, there are utilities sometimes consider certain assets to be, absolutely you can't put anything down there. I mean, we use lasers, which even though they're class 1 lasers, it's very difficult to sort of ATEX those kind of systems. But if you have the certain steps in place in terms of the safety, then yeah, you could potentially deploy it. So suddenly we found ourselves that we brought in core technologies, which are, I would argue, are not sort of pioneering in that sense, but have been sort of worked on and improved for the last decade. And we sort of brought into these new sectors and sort of improved them to the specifications that the end user put to us. And at the same time, made sure that whatever the software was around it, whatever the application would add value to what they're trying to do. So that we constantly start getting feedback from them, improving the products. And I think that's how you just have to get into the door, into one vertical, make sure that that's working very well, and then you move on to the other sort of sectors. But the core of the technology, or the baseline, should be quite standard or generic in my view. That allows you to sort of take that piece of work to other industries or other sort of sectors.
Okay, great, thanks, James. I'm going to turn to you, because what I want to try and understand the role, really. I mean, companies like Rolls-Royce, which are sort of quite a single vertical supplier, but you're going to rely on a supply chain. What can you do to really enable those supply chains to happen, so that the technology gets, we do this pivot from being technology push to market pull, so that we enable that flow and we enable that supply chain to then kick in?
Well, yes, quite. I mean, so we are absolutely effectively a customer, really, in many ways. So we want there to be a supply chain for the kind of robots that we've had a hand in developing with the Cobra project, for example. So we are working with a supply chain now to investigate how we properly put the engineering kind of robustness around that, to ensure that we get a product that we can kind of rely on effectively. That we're working with Tharsis just now, and to be able to do that, we occupy the aerospace world for our kind of products, but we also operate in the nuclear industry and the power systems engineering industry as well. So there are sort of other sort of links into different verticals, I suppose. So I'm hoping that we'd provide enough of a kind of pull for that as a start, at least initially, to get a good foot in the door. That said, keep an eye out for Nottingham University, or the University of Nottingham rather, because they are working with a medical team at the moment, just to look at the crossover from Cobra into the medical industry. So that's something I expect to see some sort of notifications go out about. So that's really quite exciting. But it's all based on using exactly the same kit that we are using in the aerospace world.
But surely one of the issues there is that the certification in medical and aerospace going to be very, very different. Even so, how would you say that standards are going to then be needed to try and at least make the supply chain operate, even if there's different certification at the end of the day?
Yes, absolutely. There must be some different certification requirements. But one of the benefits we've got in many ways is we a lot of the tools we use now, probably there's someone doing an engine inspection with a video scope right now, and that has its roots in the medical industry. It's just exactly the same kit, but with a stainless steel shroud around it as a bit of armor, and it maybe be a bit longer, but it's exactly the same equipment. So there's probably some sorts of precedents that are available already to help with that as a kind of basis. But I would imagine there would have to be some level of regulator engagement, put it that way, in both camps, aerospace and medical, just to quote two. And I'd want to hope that we bring in a range of other sectors as well. And to kind of, in the root of your question, the original question from the audience was about kind of how do we get this kind of the excitement, I suppose, across a range of different sectors. And I think this is a great place to start the KTN session, but we need to figure out other ways to kind of get the message out, to kind of generate some momentum and interest, don't we? That will help.
Okay, and that's a good place to go. I mean, Mike, you've obviously you've got a system there. You've talked about it in petrochemical. You're talking about testing it out in water. So have you got some sort of insights into how we actually persuade those end users to get engaged with robotics? Is that something that you could enlighten us with? You're on mute, Mike.
Technology. We haven't really got if you like, a designated plan. It's almost like it's evolving with particularly COVID has accelerated everything. I think pre-COVID, if you looked at what they said robotics market was, say it was 5 billion annually. After COVID, it's 10 billion. It's doubled. The market size has doubled. So there's not so much as convincing them it's needed. It's providing solutions that they feel safe with. And one of the things we need to do, while I talked about being a solution provider and commodity, is actually try and turn robotics away from black box to more commodity, more understandable, more ease of use. The technical know-how is readily available, and it's not, if you like, expertise that's required in operating, servicing, and understanding its application. So there's more of making it more accessible. Is dumb it, if you want to dumb it down, robots are idiots, or it's type of thing what you want, because quite a lot of the companies we talk to, they're wanting to get into robotics and use it, but they see it more of an elitist type of service rather than the everyday. So it's turning the robotics into an everyday occurrence and requirement, rather than this elitist type, that we from a technologist we all sort of go towards. So from a commercialization, it's bringing it down to a base level.
So I think that the key there then, as you say, it's commoditization of robotics. It's trying to get that sense of, Lego building blocks and all the rest of it to come together and integrate.
Yeah, exactly. I mean, when we've done the Nautilus, because we've got, we've got Sonomatics, we've got Invatech, we've had TWI, London South Bank involved. And what we've done is each partner, I was responsible for a certain part of technology. So what we've done from a commercialization point of view is you can just have the robot as a vehicle, as a platform, but we can sell the sensing and the algorithms, etc., for doing the work, which is Sonomatics part. We can do the localization, which is, so we're looking at trying to, and this is where the cross sector comes in. Where do the individual components cross rather than the whole? So where else could we use the sensing? Where else could we use the platform? The robotic platform could hold, just be a vehicle. So that's what we're trying to achieve.
Okay, so I think we've got a little bit of time left. So, Puneet, come back to you. Commoditization, is that an area where you would see a packaging at some level, whether it's systems or whether it's individual sensors or it's software? Is that the way forward to commoditize these things, or is it whole systems that we should be selling as a sort of hire it, use it, send it back, or what's the model there?
I think the answer is depends. Again, it also depends on. I completely get the angle Mike is coming from, and obviously understand that, and kind of it's in the supply chain. I would say from a more startup perspective, I think we have to got a decision to make at the end of the day. Are we offering a service? And if you're going to offer a service, is a service from A to Z, which involves getting men down there, getting the kit down there, making sure that everything is taken care of, from health and safety to all of the traffic management or whatever we need to do, right? And if you are going to do that, yeah, maybe you will get access to much larger part of the pie. And this is something with my minimum kind of and my very, very basic limited experience that I am kind of experiencing at the moment. Like, do you actually offer a service? If that's the direction you want to move towards, then I think it is the right thing to do, to offer the whole thing as a one package. With Prometheus, we try to do the completely opposite. What we really understood that we, as a very, very small company, we don't want to focus on just one sector. We want to focus it on one sector at the beginning, where we want to sort of make sure that the technology is trialed, it's tested multiple times, and it's robust and it's proven. But then we also want to take it elsewhere. And this is why, if you look at Prometheus, right from the beginning, we looked at what is the autonomy software, what do we aim, what TRL level do we want to achieve at the end of it. The Dragonfly, which is a 3D sensing unit, we asked ourselves the same question. So we have a solution where individual systems can be taken to other sectors. So the sensors on board Prometheus can be held in your hand, walked around, and you can still create the localization and what you need. So we have seen some benefits within even Network Rail. The drone itself is further almost a year away before it's actually commercial. There are decisions to be made. Do we actually make the drone, or do we offer it as a service? But that doesn't stop us from actually commercializing certain systems. We got the sensing, we got the autonomy, which can be taken out, and you can put the sensors on other drones when they could be deployed in open pit mines, for example, not really like deployed through boreholes. So that's the kind of approach. I think if it's a very young company, then you need to think about that. But if you're from a service background and you just want to offer it as a service, then it makes sense to actually sort of offer the whole thing as a package for one specific problem or industry.
Okay, well, thank you very much, everybody. I think we've come to the end of our time for this session, but I understand that what we now need to do is to shift over to the open collaboration session. So I think I would like to just thank the panelists for all their input and answering the questions, and obviously for the videos. And I will see you on the other side into the next Zoom call in a few moments.